Hello grade 10s, welcome to this video. This video ke tlo dira le lena analytical geometry nna leina la ka ke nna George. First and foremost, ke tlo tlhalosa what does analytical geometry mean. So analytical geometry for us means the measurement of angles and lines in a Cartesian plane. What is a Cartesian plane? Give this thing the y-axis and the x-axis. So more analytical geometry, basically we study a few things and then I'm going to explain all of them step by step. The first thing is distance formula. The distance formula. So more distance formula basically ring the length, the lines or the distance between 2 points on a line. The second thing is the gradient of a line. So the gradient of a line is the ratio of the vertical change over the horizontal change. And then the next thing after the gradient is the midpoint of a line. So so midpoint means basically we are trying to find the point between 2 points, or such that the line is such that the space between those 2 points. So get the midpoint. That point exactly 2 points. And then you happen parallel and perpendicular lines. So here using this diagram on my right hand side, and then we get the distance formula, gradient. I hope you put it down or you've noted down analytical geometry grade 10. So let me start by erasing this part and then get the distance or finding the length between 2 points. So if you open your textbooks, you show data about the distance formula and finding the length of a line or finding the distance between 2 points. So let's take these 2 points A and B and try to find the length or the distance between those 2 points using the points that we're filling on. We see that A is x1 and y1 and B is x2 and y2. So according to that formula, distance formula, it says that AB is equal to, it's AB squared is equal to, in brackets, x2 minus x1 squared plus y2 minus y1 squared. So basically, this equation says if you want the length AB, then you say x2 minus x1, y2 minus y1. x2 minus x1, y2 minus y1. And then we all know to get rid of square root, or to get rid of the square, to get rid of the square, we put a square root on both sides. So we have AB squared is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Therefore, AB is equal to this thing, So, distance or the length between these 2 points A and B, we use this formula. And then, obviously, if we find the distance between B and C, it's still going to be BC squared is equal to, you plug in your values, come quickly plug it in on this first one. Again, if we have the length or the distance between A and C, again it already A minus x1, again Rabon or C, A and B, so it's still going to be the x value of this one minus the x value of this one in brackets squared plus the y value of this one minus the y value of this one in brackets squared. Then basically that's how we find the distance or the length between 2 points. So in the next video, in the video after this one, we will try the example to show you guys how to use this equation and how to plug in your values and so on. And then I'm going to move on to the second item. I said the gradient between 2 points. Okay, let me quickly erase. So the gradient, I said the change or the ratio of the change of the vertical shift over the horizontal shift. Vertical change, the y-axis. So horizontal change, the x-axis. So the changes that happen in the x-axis and the changes that happen in the y-axis. So usually we use this notation AB. Now this is the gradient. This means gradient of AB. I'm still working at these 2 points, A and B. So the gradient of AB, as I said, is what? The ratio of the change in the vertical shift. So the change in vertical shift, the change in Y, over the change in horizontal, in this horizontal plane. So it's going to be the change in X, right? So the change in Y is denoted by Y2 minus Y1 over X2 minus X1. Now this equation, you can still write it as Y1 and then Y minus Y2 and come and say, if utomile Y1, note, look at class, the denominator utomeka X1. If kodi mutomaka Y1, look at class utomaka Y1. So in this case, utomile Y2, limota se utomaka X2. So this equation, it refers the gradient of our line. Which line? This straight line. Again, we can find the gradient of these other 2 lines. Using which equation? Using the very same equation. Using, you need how many points? 4 points. 1, 2, 3, and 4. Is it fine? I hope like so this is all about the gradient, and then go that next item, parallel lines and perpendicular lines. How those 2 particular lines or line formats affect our gradient. In the next item, the midpoint. So the midpoint, we all know, or we get the point that is found between 2 points. So in my diagram, I denote it as M. Ashiona, this is my midpoint. So it's the point found between A and B, right? Such that this part A sits in country, this part A sits in country. So basically, I divide this line by 2 to get how many lines? 2 lines of equal length. So that's basically what I mean by midpoint. So how do we find the midpoint? So many people confuse the midpoint with gradient. The formula or the equations still the gradient, the midpoint, at one. So your midpoint is always going to be a point, right? So usually or a point like this, right? I know a point. The first item give the x value, the second item give the y value. So because I said divided this line by 2, it means I have to divide my x values by 2. So in this case, it does not matter the x tau, but you just take your 2x values. So I'm going to take x1 and x2. So it's x1 plus x2 over 2. Then this will give me my x value, here my midpoint. And then for the y, here the same thing. y1 plus y2 over 2, right? And then the result is x and y, which is what? My midpoint. Midpoint of which line? Line AB. This line AB. So basically, this is how we get the midpoint of a line. So let's see so far the length or the distance of a line, or the distance between 2 points. The gradient, the midpoint of a line. So I hope you guys la tlhalohanya. If our tlhalohanya, you can leave a comment mo tlase mo as you're watching this video, na le comment section if our tlhalohanya, and then re tla ibuseletsa hape and try to make another video for you guys le tlhalohanya. The last item in the ke boletse ka yona ke itse ke tlo bolela ka parallel and perpendicular lines. So let me quickly erase so that I can talk about. So I'm going to start quickly by explaining what I mean when I say parallel lines. So parallel lines are two lines that will never meet. So if we have two lines like this, let's call this line 1 and let's call this line 2. These two lines, if they never meet, then they are parallel. So you can see with these lines, they are all going in the same direction like this, so they can never meet. Usually in your book or in your papers, the tests, these two lines like this to show that we have parallel lines, right? And then I'm going to talk about perpendicular lines. So perpendicular lines are lines that form an angle of 90 degrees at the point of contact. So they are like this. If I have line 1 like this, line 2, this is line 1, then line 2, it was something like this, line 2. And at this point of contact, they form an angle of 90 degrees. That's what we mean by perpendicular lines. So let's go parallel lines and perpendicular lines. Now I'm going to talk about the effect they have more gradient in. So let me quickly erase again for the last time. So we talk about parallel lines. So we have that the gradient of parallel lines are equal. So if I were to have another line, if in my diagram I were to have another line that is parallel to AB like this, I see my line I draw here, and I say it's parallel to AB, then it means I have to show those lines or show those things. Two lines are parallel like this, right? So if I have these two lines and like you got the first item gradients, I know the gradient of AB. But if AB is parallel to this line, it means that gradient AB is equal to the gradient of this line, which is parallel to AB. So these two lines are parallel, they have the same gradient. Please guys, do not forget this one. It's very, very important. You'll always come across it for the question. Later you want to get the question when I try to show you guys a few examples in the next video. This question, especially a parallel lines or perpendicular lines. Then let me go to perpendicular lines. So when you get to perpendicular lines, it says the product of the gradient of perpendicular lines is equal to -1. So if in my diagram like this, I have that BC 90 degrees, I have that BC is perpendicular to what? To AC. Then if these two lines are perpendicular, then the product of their gradients is equal to -1. How? Like this. So it's going to be M. Remember, we use M to show the gradient. So it's going to be like this: MBC, which is the gradient of this line BC, times the gradient of AC, which is MAC, is equal to -1. Right? So it means if you have the gradient of one of the lines, if you have the gradient of this line, if you have the gradient of BC, then you can use this equation to find the gradient of AC. go e kry yang o tlo tseya gradient ya BC wa e lokela mo na leng mo re beileng the gradient of BC, and then you solve for the gradient of AC. So in the next video ke tlo dira a few examples. I hope you guys le tlhalogantse, and then I hope le sa tlhaloganye le tlo leave or le tlo tlogela di comments in our comment section mo tlase. Subscribe to our videos, guys. Remember, subscription is to post the video, and then it will pop up. And also click on notifications so that YouTube will notify whenever we post new content. In the next video, get rid of the example. Thank you, guys. Thank you so much.